This podcast is on pH calculations and how to do them with your calculator. And the things that we're going to calculate are hydrogen ion, which is a proton, pH, POH, and hydroxide ion, OH minus. And we are going to see all four of these numbers are totally connected together. So if we have any one, we can calculate the other ones. So here is a summary of the formulas that we use for pH calculations. And these are given to you on tests, so you don't have to memorize them, but just make sure that you know how to do them, how to use them with your calculator. So the pH is equal to the log of the H plus concentration. And similarly, going backwards, the H plus is equal to the inverse log of the minus pH. These are the same equations, except they are the POH is equal to the negative of the log of the hydroxide concentration, and the hydroxide concentration is equal to 10 to the minus POH, so the inverse log of the POH. So these are both connected exactly the same way, pH and POH. Now they are related to each other in that pH plus POH equals 14. So if we know one of them, we can easily calculate the other one. Similarly, the H plus concentration and the hydroxide concentration multiplied together equals 10 to the minus 14. So again, if we know one of them, we can easily calculate the other one. So these equations are going to help us to calculate all of the numbers in the pH system. So we're going to fill in this chart. I'm going to show you how to do the first line, and then I want you to pause and try to fill in the chart yourself, and if you get stuck, then play, and I'll work through it one thing at a time, and you can stop whenever you need to. So the first thing we can see is that because we have the POH, we can use that to calculate the pH. And then we'll see next, once we have the pH, we can use that number to get the H plus. And then we can use the POH to get the hydroxide. And we are going to use the pH column to figure out if it's acidic or basic. So looking on over here, 11.8 for pH means that this is going to be a basic solution. So I'm going to fill it in, and just pause it whenever you need to and try to work it out yourself, and use the video as a guide to check and see how you're doing. Protons, and then the hydroxide, and then it's going to be basic because the pH is 11.8. Okay, are you ready? Pause now and get your calculator and work on the chart, and then check and see how you do. Okay, well, hopefully that went well. If you had any big troubles with calculating pH, be sure to see your teacher, and they will help you. We're going to do another chart just for practice. Same thing. You figure out the chart, work on it with your calculator, use the equations, don't try to do them in your head, don't try to memorize them, and then pause the video, and then play it when you're ready to check and see how you did. Okay, again, if you had any major problems, please see your teacher and they will help you. So we are going to use pH calculations to calculate the pH of solutions exactly the same way, but here, instead of given the H plus, we are given the molarity, which is the concentration, of an HCl solution, and we have to use the formula and think about how many H pluses this formula has in it. So for example, for HCl, it is monoprotic, which means that the concentration of HCl is equal to the concentration of protons because there's one proton for every HCl. So here it's pretty straightforward. The concentration of HCl is going to be the H+, and then we'll work exactly the same way that we just did and figure out the pH. So H+ is given, and we can calculate pH, just one step. So for our next one, number 2, we've got H2SO4, which is different because it is diprotic, which means for every one acid, we're going to make 2 protons. So if we had 0.056 concentration of acid, we're going to have double this number for the proton concentration. So we have to use a factor of 2 in there. Diprotic, we're going to double the concentration of acid to calculate H+. And then again, we'll use H+ to calculate pH like normal. Very, very low pH. Note, that's because sulfuric acid is such a strong acid, and this is a pretty high concentration, so the pH is going to be very, very low. So for the next one, we are given the pH of 3.6, and we're told what the acid is, and we're going to work backwards and figure out the H+. And again, because it is monoprotic, there's one H+ for every acid. It's a 1-to-1 ratio, so it is fairly simple. Monoprotic acid, the concentrations are equal. So we're going to work backwards. We have the pH, we're going to figure out the H+, and then the concentration of acid, which is what we want, is going to be equal to that number. Do some more. So in this next one, number 4, instead of an acid, we have a base solution. We have sodium hydroxide. So sodium hydroxide is NaOH. So instead of giving us H+, it's going to give us OH-. And because it has one OH, the OH- is equal to NaOH, which is given, and that allows us to calculate the POH, and then we can use the POH to get the pH. So it does require more steps. So again, KOH is going to be a base, and that's going to give us OH- from the POH. So we were given the pH, and then we can use that to get the POH, and then we can use the POH to get the hydroxide concentration, which is equal to KOH, which is 6.3 times 10 to the minus third. Okay, last one is magnesium hydroxide. Here there's 2 hydroxides for every magnesium hydroxide. So we're going to have a factor of 2. We're given the concentration of magnesium hydroxide, and because there are 2 OHs for every base, we are going to take that and multiply by 2 to find the OH concentration. So that's 0.0134, and then we can use that to get the POH, and then use the POH to get the pH. Again, 12.3 is a really high pH. That's really basic, which makes sense because magnesium hydroxide is a pretty strong base.